Again, welcome to College Algebra. This is functions and function notation. This is our Unit 2, lecture number 1. So our main objective in this lecture is to go through the meaning of the following term: relation, domain, and range. Also, we are going to understand the concept of a function and also the definition of a function, and also how to determine whether an equation represents a function. Also, we are going to learn how to find the domain of a function and also how to find the range of a function and also how to evaluate a function. We're also going to evaluate the difference quotient for a function. So first, we start with the definition of a relation, domain, and a range. So we say a relation is a set of ordered pairs. Again, we should understand this concept as a two-dimension. So a relation consists of X values and Y values, a set of ordered pairs. And again, we're going to see examples soon. So the definition is a relation is a set of ordered pairs. Then a set created by the first components in the ordered pairs is called a domain. So the domain will be the input. And also the set created by the second component in the ordered pair is called the range. So the range will be the output. So example, we can have a relation of X and Y. X will be our input and Y will be, again, our output. And also sometimes we can use the term input to be independent, and then the output should be dependent because their output value depends on the input value. So again, we will see examples. Right now, we just want to define the term relation. Again, a relation is a set of ordered pairs. And what is a domain? A set created by the first component in the ordered pair is called a domain. Then the second component, a set created by second component, is called a range. So this is our example. Here they say we should find the domain and the range of a relation. So we can see that a relation is a set of two items. So always the first value is our domain. The second value will be the range. So in this case, if I have this relation, my domain will be 2, -3, 5, and -10. My range will be 7, 13, and -11. And we cannot repeat the 13 twice, so it's still 13. So that means the solution said the domain is 2, -3, 5, and -10, which is the domain. So the domain is the first component. Now, this, which also we can say the input or the independent. Then the second value is our range. So here our range is 7, 13, and -3. So the range is 7, 13, and -3. Here they say we should note that if a value is repeated, we list it only once. So we cannot say 7, 13, -11, and 13 again. We don't need to repeat the same value twice. So now we move to the next section, which is understanding the concept of a function. So we know any relation that assigns exactly one output value for each input value is called a function. So what this means is that if I have a domain, one input value, it should determine or it should give us only one output value. Otherwise, it's not a function. So if an input can give us 2 different outputs, then it's not a function. So a relation that assigns exactly one output value, the output should be only one, for each input value is called a function. Now I can have 2 input values that give me the same one output value, is still a function. It's not a function only if we have only one input that can determine 2 or more outputs, then it's not a function. So first, again, the definition is any relation that assigns exactly one output value for each input value is called a function. So for example, if we have the equation y equal to x squared minus 1, this is a function. Why? Because every time we have different value of x, we only get one answer for y. Again, x is our domain or the input. So if the domain or the input give us only one output result, then it's a function. So here we say, for example, the equation y equal to x squared minus 1 set up a correspondence between two infinity set of real numbers, x and y, according to the rule square x and subtract 1. So y equal to x squared minus 1. Now, since the value of y depends on the number x, we call y the dependent variable, and x again is the independent variable. So always again, the domain is also called independent variable. And also range will be the dependent. So the equation determines what output value y will result from each input value x. So always x will determine the answer for y. Now, any correspondence that assign exactly one value of y to each number s, again, is called a function. So always our goal here is an input should generate only one output. Now, associated with every function are two sets of numbers called the domain and also the range of the function. So a function f is a correspondence between a set of input values x and a set of output values y, where to each x value there correspond exactly one y value. Now, we said earlier time the domain is the set of input values. It's also called the domain of the function. And the set of output values y is called the range of the function. So we say the domain is, if we are using variable, then domain is an independent variable, and range is our dependent variable. Next, we are going to determine whether an equation represents a function. Now, first thing we should know, what is a function? As we said earlier, a function always means the input will generate only one output. If an input generates two or more outputs, then it's not a function. So now we are going to determine from these three examples if any of them is a function. So we start with 7x plus y equal to 5. Now, if I'm looking for y, remember y is our range or the dependent variable. So when we do transformation of a formula here, we send positive 7x, cross the equal sign, it becomes minus 7x. So here we have y equal to 5 minus 7x. This is a function because we can see that anytime we have any value of x can be any value, we always get only one output for y. So this is a function. So we say from this equation, we see that for each input value x, there correspond exactly only one output value of y. The equation defines y to be the function of x. So y equal to 5 minus 7x. Now let's try the b. The b, we have absolute value x plus 1 equal to y. This also is a function because I can say that any value we have for x, we are going to get only one y value. So here we say since each value or each input number x that we substitute for x determine exactly one output y. So the equation y equal to absolute value x plus 1 defines y to be the function of x. Now first, let's see the c. Y squared equal to x plus 2. Now we can see that if we are looking for y will be plus or minus square root of x plus 1. So this means anytime we have a value of x, we can get more than one value for y because we're going to get plus x plus 1. plus s and minus. So note that each value s for which the function is defined, except -2, gives 2 outputs. -2 will give us 0 because positive, negative, 0. 0 is 0. It's not positive or negative. But if the answer is 3, then it can be positive 3 and negative 3. If the answer is 100, positive 100, negative 100. So because if s equal to 1, we are going to generate 2 answers for y. It's not a function. Now let's move on how to find the domain of a function. So the domain of a function, again, as we said earlier, is a set of all real numbers x for which the function is defined. And always s is the first term. Thus, now to find the domain of a function, we must find a set of numbers that are permissible input for x. So how this works, let's see an example. Now, if I have a function y equal to 1 over x squared minus 5x minus 6, they say we should find the domain of this function. As we said from the definition, the domain of this function will be any permissible value of x that will give us an answer for y. So we can see that if the value of x here gives us 0, we are not going to get an answer for y because any value divided by 0 does not exist. So that means in this domain of this function, we are going to look for a value that if we substitute here, we get 0, does not exist. So that's the first thing we did here. We take the function s squared minus 5s minus 6 equal to 0. Then we find out that we factorize the trinomial, we get s minus 6 times s plus 1. So we are using minus 6 plus 1. Minus 6 times plus 1 will give me minus 6. Minus 6 plus 1 combined together will give me minus 5. So that's correct. So first we get s minus 6 is equal to 0 and s plus 1 also equal to 0. So our first input value will be 6. Our second input value will be -1. Then now we can set the domain. So the domain, since we have up to -1, the domain will be from -infinity to -1. And this means a union or n or. So from -infinity to -1 and -1 to 6 and 6 to positive infinity. That will be our range. That will be our domain. This is the x domain. Now, how to evaluate a function. So here we have a function notation always we said y equal to f at x. So we read this as f at x. So here we say to indicate that y is a function of s, we often use function notation and write as y equal to f at x. The notation normally provides us a way of denoting the value of y. And the value of y is the dependent variable that will correspond to some input numbers x, which is our independent variable. So let's see an example here. Let's say we have a function g at x equal to x squared plus x minus 4. Now they say we should find g at -3. This means anywhere we see the value of x, we are going to substitute it with -3. So we can see g at x equal to 3x squared plus x minus 4. So g at -3 means 3 times, instead of x squared, to be -3 squared, plus, instead of x, it will be -3 minus 4. So we know -3 squared will give us 9. 9 times 3 is 27. This will give us -3, and this will give us -4. So -3 and -4 will give us -7. And 27 minus 7 will give us again 20. Same thing if we are going to look for g at k. It means anywhere we see x, we are going to substitute with k. And the same thing here, g at negative t cube. Anywhere we see x, we are going to substitute with t, negative t cube. And g at k plus 1, anywhere we see x, we are going to substitute with k plus 1. So let's go to the b. We are looking for g at k. So b, our function is g at x equal to 3x squared plus s minus 4. So g at k will give me 3. Anywhere I see x, I'm going to substitute with k. So it will give me 3k squared plus k minus 4. And that will be our solution. Now we have c, which said g at x is the same equation 3x squared plus x minus 4. Now we are looking for g at negative 3 and t cube. Again, g at negative t cube. So anywhere I see x, I'm going to substitute with negative t cube. So we have 3 times negative t cube all square, because we have s squared. So s represents t cube and is square, plus s represents negative t cube. So we get negative t cube minus 4. Now we know if 2 exponents are at the top, we can multiply. So here we get 3 times 2 is 6. And then here we have t plus and minus will give me negative t cube. And we already have 4, so negative 4. What we, here again, the sign here changed to positive. Why? Because when we square t cube, it will be negative square. Negative square means negative times negative. So negative times negative is positive. Then 3 times 2 is 6. Here we have positive times negative. So we have negative. Now the last one is the D. We are looking for g at k plus 1. So anywhere we see x, we are going to substitute with k plus 1. So we get k plus 1 square plus k plus 1 minus 4. Then we get k square plus 2k plus 1. Again, k plus 1 square means k plus 1 times k plus 1. And when we multiply, we get k square plus 2k plus 1 plus k plus 1 minus 4. So now we can combine the like term. The first thing we're going to do is to remove the parentheses here, then combine the like terms. So we get 3 times k square will give me 3k square. 3 times 2 will give me 6 and a k. 3 times 1 will give me 3. Plus k plus 1 minus 4. So we combine the like term. You can see plus 3 plus 1 will give me plus 4. Plus 4 minus 4 will give me 0. So they cancel. And then we have plus 6k plus k. So that will give me plus 7k. Then we have only 3k square. So our final answer will be 3k square plus 7k. So next, we're going to learn how to evaluate the difference quotient for a function. So the example here given to us, if we have a fraction f at s plus h minus f at s over h, this is called the difference quotient, and it's important in calculus. From this expression here in calculus, we were able to derive all the calculus formulas: sum, rule, subtraction, multiplication, quotient, etc. And also we can use this formula to find the limit. But again, the main goal is finding a derivative of a function. We can use this formula. So it's a very important formula in calculus. Now, the difference quotient can be used to find a quantity such as the velocity of a guided missile or the rate of change of a company's profit. So example here, if we have f at x equal to s squared minus 2s minus 5, And they say we should find f at s plus h minus f at x divided by h. So first, anywhere we see x, if I'm looking for f at s plus h, it means anywhere we see x, we are going to substitute with s plus h. So here we're going to get s plus h all square minus 2 times s plus h minus 5. And that's equal to f at s plus h. So that's what we did here. So first we find f at s to be the same thing. F at s is s squared minus 2s minus 5. So from the formula here, f at s will also give us the same s squared minus 2s minus 5. But f at s plus h will give us, anywhere we see s, we substitute with s plus h. So all square. Minus 2, we have x, we substitute with s plus h minus 5. So we open the parentheses, s plus h all square is same as saying s plus h times s plus h, which will give us s squared plus 2sh plus h squared minus 2 times x, 2s, minus 2 times h, which will give me minus 2h minus 5. So here we are going to combine all the possible items. We have s squared by itself, and we have only 1, 2sh, and we have only 1h squared, and then 2s minus 2h minus 5. So now the answer here we have is for f at s plus h. The formula is f at s plus h minus f at x divided by h. So I'm going to subtract the value I have here, which is the value for f at s plus h, minus the answer for f at x. Then we divide by h. We are using the formula here. So here we again combine the two terms, f at s plus h minus f at x. So this will give us s squared plus 2sh plus h squared minus 2x minus 2h minus 5. And minus f at s will give me s squared minus 2s minus 5. So we combine the like terms. We saw minus s squared here, and we have s squared here, so they will cancel. We saw 2sh is only 1. H squared is only 1. But minus 2x, we also have plus 2x, so they cancel. And when we, again, evaluate all the terms here, combine the like terms, we will get 2sh plus h squared minus 2h. We also see minus 5, cancel plus 5. So now we know from the formula is f at s plus h minus f at x divided by h. So we are going to divide the solution here by h. So we can see that h is common in the expression. So we bring h outside, and we get 2x plus h minus 2. And we cancel the h. So our final solution will be 2s plus h minus 2. So next we're going to solve one example on applications, solving applications involving functions. So our example here said we have a target heart rate f at x in beats per minute, at which a person should train to get an effective workout. Is a function of a person's age x in years. So if f at x equal to 0, negative 0.6x plus 132, we should find a target heart rate for 20-year-old college student. So x represents our years. So our answer will be negative 0.6 times 20 plus 132. Then the answer we get will be the target heart rate for a 20-year-old college student. So we substitute S for 20, and we get 120. So 120 will be the target heart rate which is 120 bits per minute. So again, this will be the conclusion of our lectures. Again, in these lectures, we focus on what is a function, how we can determine a function, and also we went through what is the domain, range, relation, etc. So again, wish you the best. And if you have any question, again, send an email. Thank you.